Hello guys, welcome back to Learn the Concept. Uh, in today's session, we will be talking about ANOVA, which is a continuation of parametric tests after t-test. So, uh, the ANOVA as a test. So, the full form of ANOVA is analysis of variances, and this test is used in place of t-test when we want to compare the means across three or more groups. So t-test is limited in the sense that it could compare the means between two groups, but if we want to compare across three or more groups, right? So for example, income across marital status, married versus single versus divorced, right? So three categories or more than three categories also, we could use the analysis of variance or the ANOVA test for that. Okay. So we will be using a built-in data set called empty cars for this. Empty cars data set, we can look at the structure of the data set, right? It has so many columns. So it has basically 11 columns or 11 variables and it has 32 observations. If we just look at the data, we will get to know that it has, columns like miles per gallon, cylinder displacement, etc., etc., right? So details about uh, the different, aspects of cars. So we will be using this data to perform our analysis. So what we will do is there is a variable called cylinder here, right? So number of cylinders in the engine, right? So number of cylinders in the engine here, right? We could see that it's a numeric column right now with 6, 4, 8, etc. So what we can quickly check is that how many different variables are there, how many different values this variable basically takes, right? To confirm that, we'll run this table command and we see that there are three different types of cylinders present in the engine, which is 4, 6, and 8, right? Out of the 32 observations, 11 have 4 cylinders, 7 have 6 cylinders, and 14 have 8 cylinders. So we'll just convert it into a factor so as to make it a categorical variable instead of numeric, right? And then we will run the ANOVA, which is the function here is AOV, which stands for analysis of variance. And we will run the ANOVA between miles per gallon, which is also known as the mileage of the car, and the cylinder, which is the number of cylinders in the car, right? This is simple syntax for that, and we will print out the summary. So we see, so here the null hypothesis of ANOVA is that there is no significant difference between the groups, right? So there is no significant difference in the miles per gallon between the different cylinders, right? So it basically to say that the number of cylinders does not have a bearing on the mileage of the engine, right? But the summary here, the p-value comes out to be less than 0.05, which means that we reject the null hypothesis, which means that there is a difference, significant difference between at least one of the groups, right? Between the miles per gallon offered by at least one of the pairs of the cylinders. So we check for certain assumptions of ANOVA. For example, the residuals must be normally distributed, which comes out to be true, and the variances between the two groups must be equal. So it comes, so basically the variances here, they do come out to be statistically different, right? Because the p-value is less than 0.05, which means that there is a difference in the variances, and hence ANOVA ideally should not be used here in this form. But since we have already used it, let us continue discussing on that, right? So of course, technically, we should not have used ANOVA. We should have used something called as a wedges ANOVA test, which is a slight variation of ANOVA, but we could still continue discussing the results, right? So the result did tell us that there is a significant difference in the miles per gallon between the different cylinder groups. So now to know that which of these are different, we could use something called as a post hoc test, and which is called as a Tukey HSD test or a Tukey honestly significant differences test, right? Which will give us that. between the different combinations of cylinders, 6, 4, 8, 4, and 8, 6, it will offer us p-values to say that among which of these groups is the mileage significantly different, right? Here we can say that the p-value is less than 0.05 for all of these, which means that there is a difference in the mileage between each combination of the group, right? So, and we could see that 6 to 4 is -6, which means that 6 cylinder engines offer lesser mileage than 4. 8 cylinder offers lesser mileage than 4, and 8 cylinder offers lesser mileage than 6. So the highest mileage is with 4 cylinders, then with 6 cylinders, then with 8 cylinders, which also kind of make complete sense, right? Then we have so since this Levine test failed, we know that the variances between miles per gallon and cylinder are not equal, and hence technically it violates the one of the assumptions of the ANOVA, right? So in order to make this test work, we use something called as a Welch's ANOVA, which is the our syntax for this is this one-way dot test, right? And here also we could basically see that the p-value is less than 0.05, which again points to the same fact there's a statistically significant difference between the different cylinder groups in terms of their mileages. And yeah, that basically concludes our discussion on ANOVA. So thank you for your time. If you like the content on this video, please do subscribe to our channel and share it with your friends as well. Thank you.